Good morning, everybody. It is time to learn some math once again with Mr. Duncan, and we're going to jump right in. We start with a whole bunch of pictures, or a whole bunch of lines to the right here. There they are. They all appear to not be touching. This is because all of the lines to the right are called parallel, which means they never touch. Notice their slopes are all, or another word for slope, rate of change. All of their slopes or rates of change are all the same. You can look at that right here. We have the equation of one line, y equals x plus 5. Another one. Oh, this is not working. Anyway, another one, y equals x minus 3. Another one, y equals x. A final one, y equals x plus 1. Notice the coefficient to x in every one of these is 1. Right before the x there, before the x there, before the x there, before the x there. So every one of these has the same slope. Well, that makes sense for parallel lines because if they didn't have the same slope, that would mean they would have a different rate of change. So if, say, the blue line went up 2 over 2, and say the red line went up 3 over 2, then eventually these two lines would intersect. We don't want that because we want them to be parallel, so they're going to have to have the same slope. Okay. And the answer to that next one was because eventually they would intersect. Notice this also works for vertical lines, vertical and horizontal lines. All vertical lines are parallel. Let's go ahead and write that. All vertical lines are parallel, and this is the symbol for parallel. It's kind of like a slanted 11. And all horizontal lines are parallel. Okay, so let's jump right into start answering questions. Which line is parallel to y equals negative 3x minus 17? Well, all we have to do here is look at this equation. This is y equals mx plus b form. So my slope is going to be right there, right in front of the x. So my slope is negative 3. Now to say that two lines are parallel, all I care about in the equation is finding an equation that has the same slope of negative 3. Do we see any of these other that have a slope of negative 3? A, right here. That has the exact same slope because the slope is negative 3. That's the only thing I care about. I don't care about my y-intercepts. For finding lines to be parallel, all I need is the same slope. So the answer is A. Okay, moving on. Which line is parallel to y equals 0? Well, if you're looking for y equals mx plus b form, you could do that. This is really the equation y equals 0x plus 0. And you could see that the slope is 0 there. So we need another one that has a slope of 0. Well, it turns out that this is really y equals 0x plus 5. Notice they have the same slope of 0. However, you don't really need to do this because this right here, if we were to graph y equals 0, I'm going to sketch it real quick. The line y equals 0 is a horizontal line right on the x-axis. So if I were to graph that and then try to graph this one as well, y equals 5, it's just another horizontal line with a y-intercept of 5. So remember how we said all horizontal lines are parallel? Well, look for any two lines that look the same, y equals 0, y equals another number. Those are always going to be parallel. Which line is parallel to y plus 1 equals negative 3 times x minus 6? Well, this might stump you for a second, but just remember this is in point slope form. Y minus y1 equals m times x minus x1. And I don't really care about anything other than my slope, which is the m part. M is negative 3. All I need to do is find one of these other equations that has a slope of negative 3. There, looks like a negative 3. It's got to be that one because that's in y equals mx plus b form, and I know my m is negative 3. Moving on. Which equation represents a line parallel to the graph of 2x minus 4y equals 16. Well, now we have this in standard form, and remember the equation for standard form, ax plus by equals c, and I don't have my slope anywhere in there, so I need to actually rearrange this equation. We're going to just massage it around, as you will, and find what y equals here. So 2x minus 4y, if we solve for y, we'll know the slope. First off, subtract 2x from both sides. I'm going to get negative 4y equals negative 2x plus 16. Next step, divide by negative 4. Divide by negative 4, and divide by negative 4. I get that y is equal to, well, a negative divided by a negative is a positive, and 2 divided by 4 is 1/2, so I have 1/2 x, and then 16 divided by negative 4 is going to be negative 4. So this is my equation here, but that's not the answer to this question. All I have is an alternate form of writing the original equation. I was given 2x minus 4y equals 16. This is identical to that. We say that the two equations are equivalent. So I now know that my slope is 1/2. I just have to find one thing over here that has the same slope. Hey, A is getting a lot of action today. It is y equals 1/2 x minus 5. Oh, we're already up to a your turn question. Go ahead and try to answer that one on your own while I skip ahead. Number 6. Oh, I've already given everyone the answer. Didn't mean to do that. Which of the equations represents a line parallel to the y-axis? What I'm going to have to do in my head or on paper here is actually sketch the y-axis real quick. That's this line right here. Well, I know that the equation of any vertical line is x equals some number, and because it's the y-axis, all of the points on there are where x equals 0, and so we have the equation of the line x equals 0. All I need now is another thing that looks like that, x equals 0. Well, we can immediately cross off y equals and y equals. However, we have two now that look like they might be pairs. X equals y and x equals 4. Do not be fooled, however. This one is not your friend. X equals y, or y equals x, is the line that looks somewhat like that. I'm just going to move it up because it actually goes through the origin. This is really y equals 1x plus 0. That is nothing like x equals 0. If it has a y in it, it is not going to be parallel to x equals a number. We're looking for another equation where it is x equals a number, and our answer is B. Let's move on. In the diagram to the right, two lines form well, what do they form? If you look at them, you can see that they form a right angle. Okay, these two lines form a right angle. Anytime two lines intersect at a right angle, we say that they are perpendicular. This is the other word we like to throw around with parallel. Parallel means they never meet. Perpendicular means they meet at a right angle. So what we're going to do is we're going to try to figure out what the slopes look like on each of these. And I will actually just tell you the slopes on these because it is not very clear where the lines are here. So it turns out that the slope for the blue one is going to be something like, we go up 5 when we go over, well, anyway, I'm going to make something up. Let's say that this slope equals 4. I did not pick the best diagram for this, but let's say the slope here equals 4. Well, then I know that if I were to find the slope of the other one, I would find that this is the slope equals 4 for this one. If I were to find the slope for the other one, I would find that the slope equals negative 1/4. And so what we say is that when we have perpendicular lines, their slopes will not be the same ever Instead, they will always be opposite reciprocals of one another. What I mean by that, if I take one slope of 4 to find the slope of a line perpendicular to it, I turn 4 into a fraction. Oops, sorry, not what I meant to do. I turn 4 into a fraction. I turn that fraction into its reciprocal, and then I change the sign, -1/4. And we'll do some practice on that one on the next page. But it turns out that every time you have perpendicular lines, their slopes are going to be opposite reciprocals. So let's just practice that for a second. If I have a slope of 3 in the left-hand column here, remember my steps. First, fraction, then reciprocal, then opposite reciprocal. And I want to try to find the opposite reciprocal of every one of these. So 3 as a fraction is 3/1. The reciprocal of that, 1/3. And the opposite reciprocal is -1/3. That simple. Let's do the next one. 5 goes to 5/1. The reciprocal of that, 1/5. And the opposite reciprocal, -1/5. If you do it as a progression here, you'll never make a mistake with your signs. But it is possible to do it without using this many steps. Now, we start out with the fraction 1/2. We already have it as a fraction, so we don't really need to do that. But then when we go to turn it into a reciprocal, we have 2/1, which is really just 2. And then when I go to turn that opposite, I have to put a negative, and I'm not going to write the fraction again because 2/1 is just 2. So my fraction, or my opposite reciprocal, is -2. I'm going to leave the rest of them to you, but I just want to do this last one with you. If I start out as a fraction, I have -3/2. When I turn that to its reciprocal, it is -2/3. And when I take the opposite of that, notice I already started negative, so I don't turn it into a negative. I instead turn it back positive, and I get that my opposite reciprocal is 2/3. So every time you take the opposite reciprocal, the sign is going to flip. It doesn't always end up negative, but if you start positive, it ends up negative. If you start negative, it ends up positive. The opposite reciprocals will always have different signs. Which line is perpendicular to y equals -3x plus 2? Well, this is just as easy as the ones we were doing before. I'm looking for a slope. Instead of having the same slope, -3, I'm now looking for the opposite reciprocal. Opposite of negative is a positive. The reciprocal of 3 is 1/3, so I'm looking for a slope with 1/3. It's going to be that one right there. Moving on. Which line is perpendicular to y plus 2 equals -3 times x minus 6? Again, this is y minus y1 equals m times x minus x1. So once again, all I care about is my slope. If I start out with a slope of -3, I turn that into a fraction, -3/1, turn it into a reciprocal, -1/3, take the opposite, 1/3. I'm looking for something with a slope of 1/3, which is clearly question B. Number 9. Which statement describes the lines whose equations are 3y equals x plus 12 and 6y equals 2x plus 6? And let's look at my choices. They are segments. Clearly false because we're only talking about the equations of lines. A segment is a part of a line. These are actually full lines, meaning they go on forever in both directions. The next one, they are perpendicular to each other, they intersect each other, they are parallel to each other. All of these I can answer by finding my slopes. I don't know which ones of these choices are correct until I actually find my slopes. I'm going to give myself some more room. I need to find the slope of each of these, which means I need to move these equations around to get y equals. This first one, all I have to do is divide by 3, divide by 3, divide by 3. I get y equals 1/3 x plus 4. So the slope of the first one is 1/3. Now if I find the slope of the other one, I can compare them. The second one, all I have to do is divide by 6, divide by 6, divide by 6. I get y equals 2/6 x plus 1. However, we should all recognize that 2/6 is really 1/3 in a lot of makeup. So my slope is really 1/3 because it's 1/3 x plus 1. And so I have my slope there. I have my slope here. All I have to do is compare the slopes. Because they are the same, I know that the lines are parallel to each other. And so they will never intersect, and they are not perpendicular. Number 10, your turn. Which statement describes the lines whose equations are 2y equals negative 5x plus 12 and 5y equals 2x minus 15? I leave that one for you to do, and we move on to the next one. Which line is perpendicular to y equals 0? Well, remember, y equals 0 is a horizontal line, and what I want to be perpendicular to a horizontal line. What's perpendicular to horizontal? Well, vertical. If you have one line like this, a vertical line will meet it at a right angle. So I need a vertical line. All vertical lines have the equation x equals some number, so it's going to be d. And let's talk about that. The rule for using opposite reciprocals will also sort of work for horizontal and vertical lines because of this. Horizontal lines have a slope of 0, meaning we're going to have a line that looks like this. The slope is 0 because you're not going up and you're not going down. The opposite reciprocal of 0, well, if I take my slope of 0, 0 as a fraction is 0 over 1, say. And then when I take the opposite reciprocal, I get 1 over 0, and then I go for the negative reciprocal, negative 1 over 0. Well, as we all know, you cannot divide by 0. It just doesn't make any sense. So what we have is the opposite reciprocal of 0 is undefined. However, since vertical lines have an undefined slope, because remember when we were talking about slope, a vertical line has an undefined slope. So since vertical lines have an undefined slope, we know that horizontal lines and vertical lines must be perpendicular to each other. Okay? So we're actually sort of using the same kind of reasoning, but all you really have to remember is that all horizontal lines are perpendicular to all vertical lines. Let's do one question to sum this up. Antonio and Andre are both saving up to buy a PS4 and have decided to put their entire allowance towards saving for the purchase. Antonio starts with $50 already saved and makes $10 per week in allowance. You know what I'm going to do? I'm going to stop reading. I already know that I have $50 already saved, $10 per week. That's my rate. I'm going to write the equation for Antonio. I can't actually use A, so let's use Antonio. How about T for Antonio, because there's a T there, and D for Andre. There's a D there. So I'm going to write my equation before I even finish reading the question, because it's so easy to do. $50 already saved and $10 per week. So I know that my savings, S, for Antonio, actually, we didn't even need variables for Antonio and Andre. So the savings for Antonio, so S for Antonio, I'm just going to write it like this. Antonio's savings, S is going to equal, he's already got $50 and he makes $10 per week, so 10 per week, 10 times W plus 50. For Andre, I have a different equation, which we will read now. Andre's allowance is the same. So if he is making the same allowance, that means he's making the same amount per week. I know that he's also going to have 10W, but he only started with 25, so his equation is plus 25. If their money saved S equals 10W plus 50, and S equals 10W plus 25. If their money saved were graphed against the amount of time that's passed, so S against W, what we would do is put W on one axis and S on the other. If we graphed both of them, what relationship, if any, would the two graphs have? So once I gave you the hint that you can figure out the equation for each line. Once I have finished writing the equation for each line, all I need to do is look at the slopes to compare the lines. They both have the same slope, so it doesn't really matter about the starting point in order to talk about the relationship between the two lines. It turns out they have the same slope, so these lines will be parallel. If you were very smart, or if you thought for a little bit, you can answer that question without actually writing anything down, just by noticing that here is a rate, $10 per week, and Andre's allowance is the same, so he also has $10 per week. Whenever your rates of change are the same for two equations, they are always going to be parallel. That is all I have. Enjoy the rest of your day.